In this video, we're doing another example with abstract fractional equations. We call it abstract because we've got variables involved, and fractional because we've got fractions involved, obviously. So we've got this equation, we've been asked to solve for a, and we can see that the variable a is right here in the denominator of this second fraction. So that's what we want to solve for. A doesn't exist anywhere else, so we need to get this a by itself. The first thing we need to do in order to get a by itself is find a common denominator between the fractions on the left-hand side. So what we want to do is multiply this fraction here by y over y, and multiply this fraction here by a plus b over a plus b. When we do that, we'll have a common denominator of quantity a plus b times y. So multiplying through, this is going to be a distributive property problem where we do quantity a plus b times mx. So we say mx times a gives us mxa, and mx times b gives us mxb, so plus mxb, and that's all over quantity a plus b times y. Then for our second fraction here, we just have d times y in the numerator, so we have dy in the numerator, and in the denominator, quantity a plus b times y. That'll all be equal to p, of course, on the right-hand side. Now we need to eliminate the fractions from the left-hand side, which we can do by multiplying both sides of our equation by this denominator from the left-hand side. So we're going to multiply both sides of the equation, like this, by the denominator, quantity a plus b times y. That'll get the denominators to cancel on the left-hand side, leaving us with only the numerators. So we'll get mxa plus mxb plus dy is equal to, and here's where we multiply p by quantity a plus b times y, we'll do py times quantity a plus b. Now the left-hand side is going to stay the same, but on the right-hand side we have to distribute the py across the quantity a plus b, so py times a gives us a py, py times b gives us bpy. Now we need to put all of the terms involving a by themselves on one side. So the only terms that involve a are this mxa here and this apy right here. None of the other terms involve a, so we want to get these two terms together on one side. So we'll subtract apy from both sides minus apy. That'll get positive apy and negative apy to cancel over on the right. And on the left, we'll be left with mxa minus apy. We're also going to go ahead and subtract mxb from both sides minus mxb. So we get positive mxb and negative mxb to cancel. And we're going to subtract dy from both sides minus dy so that we get positive dy and negative dy to cancel. So that leaves us with just the mxa minus apy on the left. And then over here on the right, we have bpy minus mxb minus dy. Now we can factor an a out of everything on the left-hand side. So when we factor out an a, that's just going to leave us with mx minus py when we eliminate the a from both of these terms. And then on the right, we have equals the same thing. Now before we go ahead and divide both sides through by quantity mx minus py, let's make sure we've got all of our variables ordered correctly. So it's customary to list the variables in alphabetical order. Mx and py are okay, bpy is okay, but here we have mxb. It would be best just to change this to bmx so that it's alphabetical order. So we have bmx instead of mxb, and then dy is okay. Now we'll go ahead and divide through both sides by mx minus py. Over here we have mx minus py. That'll get quantity mx minus py to cancel on the left, leaving us with just a on the left, and that's going to be equal to bpy minus bmx minus dy, and in the denominator, of course, mx minus py. That's the process we went through to solve for a, because we were asked to solve for the variable a, but we could have done the same thing to solve for b or m or x or y or d. It would have just been a matter of eliminating our fractions by finding a common denominator and then multiplying through both sides of the equation by that denominator, getting everything multiplied out like this, so we did this distributive property, so we had everything multiplied together, and then collecting the terms together that contain the variable we were interested in solving for, and then factoring that variable out and dividing both sides of the equation by whatever was left over here to get the variable by itself.